Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 13th, 2025. This paper, released just 5 days ago, reveals that even top LLMs fall short of human experts by nearly 50 percentage points when trying to find bugs in code. The paper is titled, "Can LLMs Generate High-Quality Test Cases for Algorithm Problems? TestCase-Eval, a systematic evaluation of fault coverage and exposure." Alright. So the core question is whether LLMs can create truly effective test cases for complex algorithms, the kind that find subtle, hidden flaws. To investigate, this paper introduces a new benchmark called TestCase-Eval. It focuses on two tasks. First, fault coverage, which checks if an LLM can generate a diverse set of tests to find many different errors. And second, fault exposure, which is about crafting one single targeted test to break a specific piece of faulty code. The authors tested 19 LLMs against human experts, and the results are fascinating. Also, the authors shared their implementation on GitHub. If you check it out, you'll find everything you need to reproduce their work, including the scripts to generate test cases and run the evaluations. They also provide the full dataset and instructions to get started with their TestCase-Eval benchmark. So this first figure gives a great overview of how the TestCase-Eval benchmark actually works. It all starts on the left, with 500 problems and thousands of incorrect human-written solutions collected from the competitive programming site Codeforces. Then, for the two tasks we discussed, the LLMs are prompted to generate test cases. Finally, these tests are run in a secure sandbox, which is an isolated environment to safely execute code. A test succeeds if it makes the incorrect code fail. The authors also tested prompting methods like chain of thought, which encourages the model to reason step by step before giving an answer. Moving on to the first set of results, these charts focus on that second task, fault exposure, which is about breaking a specific piece of bad code. The top chart really highlights the benefit of using chain of thought prompting for all three models shown: GPT 4.1, GPT 4.1 Mini, and QN 2.5 Coder 32B. Performance is consistently better when the model reasons step by step. Then, the bottom chart breaks down that same task's performance by programming language. And it's pretty clear. The models are much better at finding bugs in Python code than in C++ or Java. This table then lays out the main results across all the models they tested. On the left, you have task 1, which is fault coverage. The columns there, like C at 1 or C at 20, show the percentage of different faults found when the model generates 1 or 20 test cases. On the right is task 2, fault exposure, and here we see the overall success rate. The most striking thing is the gap between the human expert and the LLMs. Humans expose over 93% of faults, while the best model, QN 332B, only reaches about 44%. Drilling down a bit further into that fault exposure task, this table breaks down performance by the specific type of error the models were trying to find. The columns show different failure modes, like WA for a wrong answer, which is a logical error, and RE for a runtime error, where the code crashes. Then you have TLE and MLE, which are time limit exceeded and memory limit exceeded. And what's really clear is that the models are much better at finding those logical or runtime bugs. Their scores are consistently lower for finding resource-based faults. So to wrap things up, the research here really shows that while LLMs are making progress, there's still a huge gap between them and human experts, especially for that tricky fault exposure task, where humans hit over 93% success. The best models are still below 45%. Even with advanced prompting and strong open-source models leading the pack, generating truly high-quality, targeted test cases for complex algorithms remains a major challenge. The findings really underscore the need for more research. That's all for this episode of the AI Research Roundup. Thanks for tuning in.